Hi guys, so here is some notes. I thought you guys might benefit from having some verbal notes instead of just seeing them written down in OneNote for the next sections. I needed just 10 more minutes to get through this, so hopefully this will help you guys. Where we left off in class was we were simplifying algebraic expressions. So first let's talk about an algebraic expression is going to be simplified when it contains no parentheses and no like terms. So parentheses and like terms are what we're looking to get rid of. So let's first talk about like terms. So terms whose variable factors, letters and exponents are exactly the same. Those are what we call like terms. Okay, so let me talk about that. So the variables and need to be exactly the same. When we talk about variables, we're talking about letters and exponents. So you can also say that they're basically the same letter variables, so same letters, raised to the same power. I'm going to say powers because sometimes there can be more than one variable. So same variables raised to the same powers. So when we have like terms, what we want to do is we're going to combine them to simplify. So this next part, combining like terms. Combining like terms is basically just combining the coefficients. So when we combine like terms, we're going to combine the coefficients. Okay, so let me show you what this looks like, and I'm going to get my highlighter going here. So in this example number 16, we can see that this is an expression that's got a whole bunch of terms here. So we need to find the ones that are like terms, that are alike. So let's just start with this first guy here, so the 2x squared. We need to find another term that is like 2x squared, meaning it's going to have an x squared part exactly the same. So the other like term to 2x squared is going to be the minus 5x squared, or subtracting 5x squared. So those are going to be what we call like terms. So when we combine them together, we're going to have 2x squared minus 5x squared. Okay, the next like terms, let's get a different color here. So notice we've got 3x to the third. So we're looking for another term that is an x to the third term. So we've got minus x to the third term here. So let's get our color coding. So we're going to add, and then we're going to add 3x squared minus, 3x to the third minus x to the third. Okay, so now let's look for some more like terms. So let's use blue. So we've got an x is one of the terms. So let's see if we have any other plain x terms, and we do. We've got a 7x. So again, that would be x to the first, even though they don't write that one. But let's get the right color. So we're going to have plus, and this would be x plus 7x. And then there is one more. Let's see, let's use orange. So the last term is going to be the constant term. So we've got plus 2 and minus 10. So that's going to be plus 2 minus 10. Okay, so those are, I kind of wrote them. That's probably more writing than you need to do. You might be able to do some of this in your head. But when we combine the like terms, so for example, the 2x squared minus 5x squared, we're just going to combine the coefficient. So think about 2 minus 5. So 2 minus 5 is going to give us negative 3. So this term becomes negative 3x squared. Notice that we don't change the x squared. It stays x squared the whole time. Okay, so we're only combining the coefficients. So let's combine the next coefficient. So we've got 3x squared minus, or 3x to the third minus x to the third. So remember, if there's not a coefficient in front, we assume that that's going to be a 1. So this would be 3 minus 1 x to the third. So 3 minus 1 is 2. So we're going to add 2 x to the thirds. And then let's look at the plain x coefficient. So we've got 1x plus 7x. So this is going to become 8x. And then we've got our constant terms. So we're going to have 2 minus 10. So that's going to give us negative 8. Okay. So this would be the simplified form of that expression. Again, all we did in that big expression was we combined all of the like terms. Now, when we're simplifying algebraic expressions, the other thing that in the description said we can't have any parentheses. So the rule that we're going to use to get rid of the parentheses is what's called the distributive property. So let me show you what the distributive property is. So the distributive property is going to be used when we've got parentheses and we've got something that we're multiplying in front of the parentheses, or it technically can be in back of the parentheses too, multiplication. So there's a multiplication, T-I-O-N. So we've got a rule for multiplication, and the way that rule looks like is I'm going to describe it using just variables. So for example, A, if I've got A times, and I've got a parentheses. So inside the parentheses, we're going to say it's B plus C, okay? And those are just kind of like placeholders, so A times B plus C. Now, what we're going to do with the distributive property is we're basically going to distribute that A to both the B and the C, okay? And when we distribute that, we're going to go ahead and multiply. So A times B plus, we're going to distribute that multiplication to the C, so this would be A times C. So when we have parentheses, again, the way we're going to get rid of the parentheses is distribute that A to both of those terms inside the parentheses. Now, this will work as well if what's inside is subtraction, so B minus C. It would look exactly the same. We would distribute the A to both of those terms. So we would get A times B, but right here we're going to have a minus A times C. So it will match the sign of what's inside those parentheses. Now, you're probably used to seeing this. Maybe you've done that before, so the distributive property. I want to make sure that you recognize that we also have a distributive property for division. So we have it for multiplication as well as for division, and it looks similar. So say I've got this B plus C, but instead of multiplying it by A, I'm going to divide it by A. So what happens when I do that is I'm going to distribute that division to both of the terms inside that parentheses. So I would distribute it to the B, and then I'll kind of make little circles, and I'm going to distribute to the A. What this looks like is I'm breaking it into two fractions. So I'll have B divided by A, and then I'm going to match the symbol, so plus, and then C divided by A. And again, this will work if I've got B minus C over A. Now I can leave the parentheses on or off. I just want you to notice those parentheses are actually not doing anything. When I split this up, this is going to be B over A minus C over A. So again, we're distributing division or multiplication. Those are the only rules. We can either distribute division or multiplication, that's it. The other important thing about this rule is that it's only for addition and subtraction inside, I'm going to say the parentheses. So we can only use it if inside the parentheses is addition or subtraction. Let me say or subtraction. So only if there's addition or subtraction inside the parentheses can we use this property. If inside those parentheses is multiplication or another fraction like a quotient, so division, we can't use the property. Okay, so let me show you what this looks like. So if I've got, in example number 17, I got -4 times this, this expression, I'm basically going to take that -4 and I'm going to distribute it to each one of those terms. So I'm going to write this out, and again, I'm going to write out probably more than what you need, just so you can see what I'm doing. So you'll have -4, and I'm multiplying that by every term. So first I'm going to multiply it by the x squared. And then I'm going to take the -4, and I'm going to multiply it by the -3x. Then I'm going to take that -4, and I'm going to multiply it by the 7. So I combine them using just all straight addition, and then I'll deal with the negative signs now. So remember, we can't have parentheses, so I just introduced a whole bunch of parentheses. So let's get rid of those by just multiplying. So we'll have -4x squared. Plus, now -4 times -3 is going to give me +12, so 12x. And then -4 times 7 is going to give me -28, so I'll have -28. Now notice again when I combined the when I multiplied them together, that I didn't actually change like the x's, like the x squareds or the x. We just multiply them and keep them the same. Okay. All right. So last one I want to go over with you guys. This one here, that p, let me zoom in a little bit for you. So that p is actually not supposed to be there. So take that out. That's a typo. I did not intend for that to be there. So this problem is one in which we're distributing division over that, that expression with the two terms. So again, when we just distribute the division, we're basically going to break it into two fractions. Okay, so those are the two fractions. So when I write this out, this is going to look like 21p divided by 6. So I'm going to divide 6 into the first term, and then I'm going to divide 6 into that next term, again, the one without the p. Okay. Now don't forget, you got to simplify. So notice that the 21 over 6 can be simplified. Both of those 21s and 6 can be divisible by 3. So I'm going to divide the top by 3 and the bottom by 3. So that ends up becoming, let's see, 21 divided by 3 is 7. So 7p on top. 6 divided by 3 is 2. Okay, and then the 30 divided by 6, that's actually 5. So this would be the simplified form. Now you can also write this, if you remember, we were talking about the coefficients of variables. So you can also write this as 7/2 p. That's fine too. That would be a good answer for this one. Okay. All right. So that kind of gives you, I needed 10 more minutes in class to cover that. That was really the last piece of the notes. Everything else in this section is practice. So I will update the practice problems so that you can have the answers for the practice problems in OneNote, but they're really for you to do to practice. If you have any questions as you're doing your homework over the week, please just let me know. Just send me a note. If you need me to do an explanation, I can do a video explanation or meet with you. Either way, that's fine. So just let me know if you need any help. Hope this helps.